So more examples of using our double angle formulas. So let's say that we have the tangent of theta is equal to 5/12 such that theta lies in quadrant 3. We want to find sine of 2 theta, cos of 2 theta, and tan of 2 theta. All right. So you might remember in the previous video with our sum and difference formulas that we draw a right triangle. All right. And that's what we're going to do first. All right. So let's say we have this is theta. Remember, tangent is opposite over adjacent. So that's going to be 5 and 12. And we know that this is going to be 13. All right, we've probably seen this Pythagorean triple a lot, but just in case we don't know it, 12 square plus 5 square equals c square. That's going to be 144 plus 25 equals c square. 169 equals c square. 13 equals c. Okay. Now, the other thing that we have to remember is the all students take calculus. And now we're looking at quadrant 3. And so what we know is that the tangent of theta is greater than 0, but that means that the sine of theta is less than 0, as is the cos of 0, okay, or cos of theta, excuse me, is less than 0, okay? So now that we know all that, let's go ahead and try to employ our formulas, okay? So sine of 2 theta, right? Remember, sine 2 theta, and we're just going to take a look at our formula. Remember, sine of 2 theta is 2 cos theta sine theta, or 2 sine theta cos theta, whichever way you want to do it. That's going to be 2 sine theta cos theta. Right? Now, the sine, recall, is going to be the opposite over the hypotenuse, and it's negative because it's in quadrant 3, so it's negative 5/13. The cosine, we already know, that's going to be 12/13 because that's going to be the adjacent, but it's going to be negative, right? And finally, if we multiply all those together, 2 times 5, that's going to give us 10. 10 times 12 is going to give us 120. 13 times 13 is 169. Negative times negative is positive. Right? So that's easy enough. Secondly, if I want to find the cos of 2 theta, okay, cos of 2 theta, remember, is going to be that formula. In fact, we have 3 of them. So cos of 2 theta is, I'm just going to use the cos square theta minus sine square theta formula. All right. And again, I do that because I know when we get common denominator, it'll make it easier than dealing with the 1. Okay. Cosine, remember, we just said cosine is negative 12/13. Okay. Again, it's in quadrant 3. We're going to square that. And then for our sine, sorry about that, I'm just cleaning that up a little bit. So negative 12/13. Our sine function is negative 5/13, and we're going to square that as well. Okay, remember, opposite over hypotenuse. So if we square this out, that gives us 144 over 169, and then we get 25 over 169, and 144 minus 25, that's going to end up giving us 119. So 119 over 169. Finally, if we want to find the tangent of 2 theta, which is going to be the easiest one, I think, we just go on to our identities. And remember, tangent of 2 theta or 2x is going to be 2 tan theta, 1 minus tan square of theta. That's going to be 2 tan of theta divided by 1 minus tan square of theta. We already know the tangent. Okay, remember, tangent is 5/12. So we could have actually done this one before we even started the problem with the right triangles. Okay, so 2 times 5/12. Okay, so just plugging that back in, divided by 1 minus 5/12 squared. Now we do have a little bit of work to do on this, but that's okay. We know how to do our algebra. 2 times 5 gives us 10/12. In the denominator, we get 1 minus 25 over 144. And then we can get a common denominator for 1 as 144 over 144. So 144 over 144 minus 25 over 144. When we simplify this, this becomes 10/12 over 119 over 144. And now we could just multiply by the reciprocal of the denominator. So 10/12 times 144 over 119. We know that 12 times 12 is 144. So this just 10 times 12 that's left over is going to be 120 over 119. Okay. All right. So it's not meant to be too difficult. Another way we could have done this to actually make it a lot easier is we could have just taken sine of 2 theta and divided by cos 2 theta. Okay. Because remember, if I have the tan of 2 theta, and this might have actually been a lot easier. Remember, tan of 2 theta would be sine of 2 theta divided by cos 2 theta. Okay, so remember, that's like a Pythagorean, that's a ratio identity. And we found that sine was 120 over 169. And we found that cos was 119 over 169. If we multiply by the reciprocal, 120 over 169 times 119 over 169 over 119, that would give us 120 over 119, which I think is the exact same thing as what we just got down here, except it was a lot tougher. But that's a way to check your answers, right? If you take the ratio of these two and they do equal what we have here, then we should be good to go. All right. So anyway, just showing you a couple different ways to do this. Similar problem, cosecant of theta is equal to negative 5/3 in such that theta is in quadrant 4. Okay. So we want to find sine, cos, and tan of 2 theta again. All right. So remember, all students take calculus. Okay. And we're in quadrant 4. So we know that the tangent of theta is less than 0. Right. We know that the sine of theta is less than 0, but the cos of theta is going to be greater than 0. Okay. So that's just by our standard definition of all students take calculus in the quadrants. Okay. Now let's also go ahead and construct a triangle out of this. Okay. So let's call this theta. Right. Now remember, cosecant, we can take the reciprocal of that, and we could say that the sine of theta is going to be equal to 3/5. Okay. So that's going to be opposite hypotenuse. And we know that's going to be 4, 3, 4, 5 right triangle. But just in case we don't know it's going to be 4, we can use our Pythagorean theorem. We can say 5 square equals 3 square plus b square. 25 equals 9 plus b square. 16 equals b square. 4 equals b. All right. So, but we should recognize some of these Pythagorean triples like 3, 4, 5. For instance, we saw the 5, 12, 13. Okay. Some of the ones that are more common we should recognize. All right. So now let's find sine of 2 theta. Okay. Remember, sine of 2 theta is 2 sine theta cos theta, which is the same as 2 times the sine. Now remember, sine is less than 0, cos is greater than 0. Sine is opposite over hypotenuse. That's negative 3/5, and we already knew that. Okay, we're up there. And the cosine is going to be positive. That's adjacent over hypotenuse. That's 4/5. And so when we multiply this through, this is going to become negative 24 over 25. Okay, so that's nice and easy. The cos of 2 theta. Okay. Remember, we can say that that's going to be cos square of theta minus sine square of theta. Right? Or in this case, we know that cos is going to be 4/5. So we have 4/5 square minus a negative 3/5 square. Right? Since we just found both cos and sine, that's going to be 16/25 minus 9/25, or 16 minus 9 is 7 over 25. All right, nice and easy for that one. Now, finally, for the tangent, now let's just use the formula. And we know if we divide these out, okay, so we know that eventually, like just if we want to get this really quickly, we could do 24/25 divided by 7/25, that trick that we just used, and the 25s would cancel. So we should end up with negative 24/7 for the tangent if everything works out okay. But let's check this, okay? So remember, tangent of 2 theta is going to be, I'm sorry, tangent of 2 theta is going to be equal to 2 tangent of theta divided by 1 minus tan square of theta. Okay, so that's our general formula. Okay, so that's given to us, oh, right here in our tangent formula. So 2 tan x, 1 minus tan square. We know that the tangent is going to be opposite over adjacent, and that's going to be 3/4. Okay, so that's going to be 2 times 3/4 divided by 1 minus 3/4 squared. 2 times 3/4 is going to be 6/4. 1 minus 9/16, or 16/16 minus 9/16, or 7/16. And then if we multiply by the reciprocal, okay, 6/4 times 16/7. And by the way, there should be a negative right here, right? Because the tangent's negative, so I do apologize. So this will be a negative 6/4, which will make this negative, okay? Finally, we know that 16 divided by 4 is 4. And so we end up with negative 24/7, okay? And by the way, the reason this is negative, don't forget that if we go back, we said that the tangent of theta is less than 0 because it occurred in quadrant number 2, okay? All right, so that's how we can go through and try to utilize our double angle formulas to be able to evaluate, given an angle for an original trig function, okay? So in our next videos, we're going to do something similar to what we did in with the sum and difference formulas, where we have these sorts of obscure angles and we're trying to evaluate them. We can use our double angle formulas to do so.